Hi. Well, you don't go anywhere, do you? Okay, I'm going to explain applications of derivatives. Now, we said revisited because the idea is the same. We're going to go with gradients and stationary points and everything. But just because we have more functions to deal with, we're going to revisit the idea. Let's start with an example. Given that y equals this expression, find dy over dx at this point. So basically we are finding the gradient here, and what you're going to do is you're going to substitute the x value into the derivative that you find, and that's pretty much it for this question. So let's start. We're going to write the function again. So that is 5x squared minus 3x plus 1 to the power of 1 over 2, right? That's the square root. And now I can take the derivative. This is basically chain rule. I'm going to treat this as u to the power of 1 over 2. So this means I'm going to write 1 over 2 times whatever is inside the brackets. And I'm going to take away 1 from the power. And then I'm going to take the derivative of what is inside the bracket. So it's going to be 10x minus 3. So that's the derivative. Now, at this point, if I rearrange this expression, it's going to be more substitution friendly. So I'm going to rewrite it as 10x minus 3 over 5x squared minus 3x plus 1. You can write 1 over 2 as power, or you may prefer to bring back the square root. That's totally fine. Of course, we have to write 2 here as well as multiplier. So what I did is that, this is at the top. So I multiplied it with 1, and I got this. And then this is supposed to be in the denominator because the power is negative, together with the 2 here in the denominator. So this is the derivative. Now, I'm going to substitute the value of x, so that's 4, and I'm going to write dy over dx equals, remember, I always have to write the substitution step, but then I don't need to show any work. So we have 2 here, 5 times 4 squared minus 3 times 4 plus 1 in the square root, yeah? And then I can just write the answer if I want. I can use a calculator, but my suggestion is calculate the top and the bottom separately. So that's going to be 40 minus 3, 37 here. And then if you use your calculator for the denominator, you're going to get 2 in square root 69. So that's the answer. So if need be, in the following questions, you'll see that we are going to calculate the gradient like that. This is actually the gradient at this point for this given function. Another example. Right, in this example, we have a function, we have a curve, and apparently we have a stationary point. Now, we end up with stationary points when we equate the derivatives to 0, because when you have a curve, you have the stationary point, and the tangent to that curve at the stationary point is horizontal, which means the gradient is 0. So when we take the derivative of a function, we end up with a gradient function. So at any point x, if we substitute the value of any x value, right, we can find the gradient of the tangent at that point to the curve, right? So this means if I want to find the gradient of the tangent line here, all I have to do is to use the same derivative but substitute that different x value to find the gradient. So this applies to any tangent drawn to this curve. All I have to do is to substitute those different x values. Anyway, so let's find the derivative first. We're going to go that's going to be the quotient rule. So let's remember that one first. The quotient rule suggests that it's going to be v du minus u dv over v squared. And here, u is sine x, so du must be cosine x, and v is e to the 2x, and dv is 2 times e to the 2x. So let's substitute these. dy over dx will be e to the power of 2x times du is cosine x minus sine x dv is 2e to the 2x over v squared e to the 2x squared. And I end up with e to the 2x in brackets cosine x minus 2 sine x over e to the 2x squared, which I'm going to cancel out and end up with cosine x minus 2 sine x over e to the 2x. So that's my derivative, and I need to find the stationary point now. This means the gradient is 0. So this expression must be 0, and I have to solve this equation now. So basically, e to the 2x has no function here because it's in the denominator. If you multiply both sides with e to the 2x, it will cancel out. So actually, I have cosine x minus 2 sine x equals 0. This means cosine x is 2 sine x. So if I divide both sides by cosine x, I'm going to have 2 sine x over cosine x equals 1. And now I have 2 tangent x equals 1, which means tangent x equals 1 over 2. Now I can write x equals, well, the interval is given in terms of radians, so I'm going to go with radians. Tangent inverse of 1 over 2, which will be 0.4636 and so on. It just says 3 significant figures, so I cut from here and write this as 0.463. Now, my angle is here and here, so 0.463, 0.463 here. So just because it is from 0 to pi, only this bit, I cannot include this as an answer, so I will exclude that. I'm going to use this only. But now I only have the x-coordinate for the point P. So I have to go back here and substitute the x value to find the y value. So y will be sine of 0.463. And I'm going to read 2 more digits from my calculator, 6, 4, just to make sure that my answer is accurate enough. And for the denominator, it's going to be e to the power of 2 times 0.46364. And the answer will be 0.17692 and so on. Now I can use 3 significant figures here as well. So my point P will have the coordinates 0.464 when I round it up, and for y value 0.177 when I round this value. Now in this example we have this curve with equation, and the question is find the equation of the tangent to the curve C at point x equals pi over 4. Now this question might give you, instead of x, a point P with the coordinates, okay? But still, we would be using the x value only. And at this point, certainly we're going to use the y value later, so we have to calculate it because it's not given. But also, this question might ask us to find the normal to the curve. And now you have to remember, if it is the normal to the curve, you know, m tangent times m normal is -1, because a tangent line and the normal to it has always got 90-degree angle in between, right? So these are the derivatives of this question. You could be asked to find a normal equation, you could be given the full coordinates of the point P, but again, it's pretty much the same in terms of the solution. So the general expression or equation for the tangent line is y equals mx plus c. So this stands for the gradient, and this stands for the y-intercept, right? Now, for the gradient, I need to find the derivative and substitute the x value. For the y-intercept, I will need, let's say this is point P, I need the full coordinates of point P, so this means I have to calculate the value of y, substituting x into the original function, right? And then I have to substitute the coordinates into the tangent equation, to find the y-intercept. So let's start. Now I have two functions here in product, so I will be using the product rule, which was dy equals u dv minus v du. So it's going to be, let me write u being x cubed, so du will be 3x squared, where v is sine 2x, that's going to be 2 times cosine 2x, because sine, the derivative is cosine, and 2x's derivative is 2, so that's dv. Now let me substitute these into the product rule. So I'm going to have the derivative with respect to x as x cubed times 2 cosine 2x plus, so that's going to be a plus, my bad, sine 2x times 3x squared. So if we rewrite this, rearranging the coefficients and everything, it's going to be 2x cubed cosine 2x plus 3x squared sine 2x. And I can also write x squared out, saying 2x cosine 2x plus sine, so 3 sine 2x. So that is my derivative. Now let's find the gradient. M is equal to, when I substitute x equals pi over 4 here, pi over 4 squared, right? Brackets 2 times pi over 4 times cosine 2 times pi over 4 plus 3 sine 2 times pi over 4. Now, when it comes to here, this is pi over 2, and we know that cosine pi over 2 is 0. So just because this is 0, all this is 0. So I have to be calculating this bit. Sine pi over 2 is 1, so I have 3 here. And this is pi over 4 squared, so I have 3 pi over 4 squared. I'm not calculating the decimal, I'm just keeping the exact value. So this is my gradient, and let's write it to the tangent equation. So my tangent line will now look like y equals 3 times pi over 4 squared x plus c. Now I need to find the y-intercept. To be able to do that, I need to substitute this into the function. So let's do that. For x equals pi over 4, y equals pi over 4 cubed times sine 2 times pi over 4. So this is pi over 2. Sine pi over 2 is 1. So basically I have y to be pi over 4 cubed. So this means the coordinates are pi over 4 to pi over 4 cubed. This is what I'm going to substitute into my tangent line equation. So let's do that. Pi over 4 cubed equals 3 times pi over 4 squared times pi over 4 for x plus c. As you can see, I have pi over 4 cubed equals 3 times pi over 4 cubed plus c. So basically c will be minus 2 times pi over 4 cubed. Again, I'm keeping the exact value, and I'm just going to substitute this into the tangent line equation, and my tangent line now will become y equals 3 times pi over 4 squared x plus, now it's not going to be plus, it's going to be minus 2 times pi over 4 cubed. That is the equation of my tangent line. As you can see, there is nothing different in the structure of finding the tangent line equation. We have to find the gradient by using the derivative, and we have to find the y-intercept by substituting the full coordinates of the point, right? But what changes is that we have now more equations. We have product rule, quotient rule, and this and that to find the derivative of a function. So that is the only difference. And that's pretty much it. And now is the time to practice. So now go back to your books and solve those questions regarding gradients, tangent lines, normal lines, stationary points, and so on. Before we leave, remember we were to find points of inflection. Now, this comes with the second derivative, yeah? So if you ever come across a question which asks you to find the coordinates of the points of inflection, you should be calculating the second derivative and equate it to 0 and look at the behavior. Now, this was in P2. You may refer to your P2 content for this. Thanks for watching.